Welcome back. It's finally time to get some more work done on the airboat. The plan for this video is we're going to finish the deck. So the deck has plate across the top. This was basically spot welded in place, and the plan is to fill in all those holes and basically make everything complete and watertight. This had been sitting out for quite a while, so there's actually a bit of grime inside there. I did the typical acetone and wire brush, trying to make everything clean for welding. This is the first TIG with a new welder. As I mentioned before, I used to have a synchro wave, and then I recently upgraded to the Miller Multimatic. I have previously I did a quick project using the MIG function. This is the first time I used the TIG. So overall it worked pretty well. In this video I'll show you a few tweaks that I made that made it better. At the end of all this, I'm actually very happy with it. It's working great. So what I'm filling in here is holes that I drilled in the plate when I tack welded it to the structure underneath. And I'm basically just filling them all, welding them solid. Where the deck meets the windshield area, there was a seam along that entire length. So basically I did the same thing, cleaned it, wire brushed it, and then ran an entire bead along the whole length. As you can see here, the Miller came with this 17 style TIG torch. At this point I had a gas lens put in it, and that worked pretty well. I ended up changing it out, which I'm not sure why I did, because that was a mistake. I ended up having to go to a gas lens again later. So overall, it was welding pretty well. I did have some issues with contamination. Part of it was probably related to the fact that the boat had been sitting outside and there was a fair amount of dirt and crud still on the metal. I did also come to find I had some problems with the shielding gas, and that actually got worse when I took the gas lens out and switched to a standard collet, and that's the reason why I did have to go back to a gas lens later. So this is the front of the deck, completely sealed up. It's got a full bead at the windshield there, and all the spot welds have now been completely filled in. So this is a shot of the back of the welder, and it's one of the features I really like about it. With this Miller Multimatic 220, both the MIG and TIG gas are connected at all times. Depending on which process you're using, it uses the appropriate shielding gas. One thing I didn't like is that I had to upgrade the flow meter on the TIG. I kept the original regulator on the MIG, but for the TIG I wanted a bit more precision. So most of the seams on the deck are welded up. There's a few things I have to do still. I have one spot here where it oil cans. So I'm going to put a brace underneath. That should solve that fairly easy. But I can't have it stay that way. The other thing that I got to do still is on this part here, I'm going to put a piece of sheet metal or plate between this. And the point of that is because I want to be able to walk on top of this. So the deck will be patched into here, and this will be completely watertight. I probably could use just 1/8, but I don't think I have any, so it's going to be 3/16. It's probably stronger than it needs to be, but we'll get that welded in. So with a skill saw and a carbide blade, it's pretty easy to cut through this aluminum sheet. I use a bit of WD-40. Usually I just spray a little bit on the blade, sometimes on the metal itself. It just keeps the aluminum from sticking to the blade. For the sides, I'm just trimming down pieces that are left over from other parts of the build. I didn't have a great selection of full-size pieces, so I had to basically cobble it together from smaller pieces. This plate was pretty much ready to go, just a bit more trimming, and it was ready to weld in. You can see that it wasn't long enough, so on both sides I had to have extra pieces to fill the full length. Here I'm using the same Miller torch, except for I've taken the gas lines out now, and now I'm using just the standard collet that came with the machine. And as I've said, this was a bit of a mistake, because I was getting some contamination issues, and part of it I think was related to the shielding gas. Part of it I think was related to the fact that I was used to using the gas lens before, and I think that, you know, the angle that I was holding it wasn't great. And at times I probably had the tungsten out a bit too far for appropriate shielding. For strength, I'm sure these would have been strong enough just to do an interrupted or tack weld. But I ran full-length beads up and down the entire thing, and the reason for that was so that it would be completely watertight in the rain or ice. I didn't want any potential water ingress. So the plate is completely welded in, but as mentioned, I need to fill the gap. On this side, I chose to use that channel to kind of split the difference, and then I used two pieces, one on either side of the channel. So here you can see the two plates at the end welded in, and the completed plate all the way up. It's not the prettiest thing in the world, but it is certainly strong. It's probably way stronger than it needs to be. On the other side, I did basically the same thing. I cut a plate, measured to size, and then welded it in at the top. So at the end of this weld, you can see something that I'm sure every TIG welder can relate to, is right at the end of the bead, I dipped the tungsten. And just for the sake of agony, let's watch it in slow-mo. But this brings me to a sidebar. During this time I decided to change the way I'm grinding tungsten. Previously I've just been using this cheap angle grinder just with a cheap grinding wheel in it. And I do make sure that I use this for nothing but tungsten. But I wanted to try a diamond wheel. So basically now I'm just switching over one of the grinding wheels to the diamond disc. The diamond disc is just a cheap 240 grit diamond wheel that I bought off Amazon for $17. It fit on there pretty easily, but I did need to use a spacer in order to get it locked down. And so far I'm pretty happy with it. It seems to sharpen the tungsten pretty quick, pretty easily. We'll see how durable it is. So as I've mentioned a couple times, I was changing the configuration of this torch around quite a bit. This is basically the 17 torch that came with the welder, although I did switch it over to a flex head, which I do like, but this was just a cheap generic flex head, so I ordered a proper Miller one. So I'm going to switch it over to the nicer Miller flex head. And the other thing I wanted to do was to go back to the gas lens system for the shielding gas. Now I've been watching welding tips and tricks on YouTube, as I'm sure lots of you guys do as well. And in his videos he seems to use the Furic glass cups. He actually sells them as well. So anyway, I drank the Kool-Aid on those ones. I thought I'd give them a try. So I ordered the Furic glass cups and the adapter, which comes with a gas lens. And so that's what I'm installing here. That's the gas lens that screws onto just the regular 17 style torch. I bought 4 of these glass cups. Hopefully I don't drop them too often. And that's about it. It goes together pretty easily. And so the advantage of these is using a gas lens, but having the increased visibility of having a glass cup. And overall it looks quite nice. It's fairly compact. I think it's a nice upgrade. So trying it out, it did take a couple beats to really adjust to the slight difference in positioning, but overall I have to say that I think this is a really good setup. It basically eliminated my contamination issues, which makes me believe that it was mostly due to a shielding gas problem. The visibility is quite good. Having the glass there does help. You're able to basically have the cup and the tungsten pretty close to what you're welding and still be able to see it reasonably well. So overall, yeah, I am completely sold on this product. I think it's quite helpful. For a novice TIG welder such as myself, I thought it really made things easier, and ultimately that improved the quality of each weld. This is just some time-lapse footage of me running the full weld down this entire plate. So again, on this side the single plate was too short, so I had to cut an extra piece to fill the remainder. On this side I had a nice enough piece that I could do it all in one. It's actually a cleaner look than the other side where I had to use the channel and the two separate pieces. So that's a completed deck on the side. And with the front and the other side all completely welded as well. Now remember the oil canning issue I had at the front there. I cut this strip of 1/8 sheet metal and the plan was to use that as a brace. In retrospect, I probably should have just used a bit of a thicker metal there. It made it a bit challenging to weld. Also, welding it upside down underneath the deck was pretty challenging. Just getting a good position to get in there and weld it was pretty tough. Eventually I found out a good way to do it where I could actually get a good weld in, but it took a few ugly welds before I figured that part out. So I'm not terribly proud of that weld underneath, but it's strong, it's underneath, it serves a purpose, and thankfully nobody will see it. So here's a completed deck. Overall I'm pretty happy with how it looks. It's certainly going to be strong. It's probably a lot stronger than it needs to be. I probably could have put a lot lighter gauge metal on the front. That would have made it lighter, but at least now it will stand up to anything I throw at it. The downside is that it does make the overall boat heavier, and my solution to that is just to give it more horsepower. Next up will be mounting the engine and building the motor mounts. Thanks for watching.